When I first did this question, I went down the wrong path. I started trying to square x and y straight away. I got cos to the power 4, and I got some cos squares over here. I did try and bring double angle formula into it, but it just didn't quite work out. So I don't think that's a good idea. I think we need to do some preliminary manipulation. And here's the first clue then. Cos t sine t. Well, there's a double angle formula. Sine 2a is equal or identical to 2 sine a cos a. So I can write this as a half sine 2t. Ultimately, we're trying to get sine t or sine 2t in one of the expressions and then cos 2t in the other expressions because then if we square and add them, we're going to get 1. And we can start to create an equation because we're trying to get essentially x squared plus y squared equals r squared, or something like x minus something all squared plus y squared is equal to r squared. So let's take a look now at the cos squared. Okay, I'm going to get a double angle formula involved here as well. So cos 2a is identical to cos squared a minus sine squared a. And we can replace sine squared by 1 minus cos squared, which gives me 2 cos squared a minus 1 as an alternative for cos 2a. That's something to become familiar with, to be honest. And that means that cos squared a is going to be identical to cos 2a plus 1 all over 2, or a half plus a half cos 2a. Okay, nice one. So that's actually what x is equal to. A half plus a half cos 2t. And I can go one step further therefore and write down that x minus a half is equal to a half cos 2t. And I haven't quite got cos 2t and sine 2t. I've got a factor of a half there as well. But actually, that's going to be okay. Let's just roll with it and see what happens. So continuing it down here, I can write down that x minus a half squared plus y squared is going to be identical to a half cos 2t all squared plus a half sine 2t all squared. This will be a quarter cos squared 2t plus a quarter sine squared 2t, so I can factorize the quarter out, and then this bit is just 1. So I've just shown that x minus a half squared plus y squared is going to equal a quarter, or I could even write it as a half squared. And we're asked to show that it was a circle. This is a circle. The center is a half 0 because it's in the form x minus a squared plus y minus a y minus b squared. And then the center is ab. And then the radius, I've written it in the form r squared, so the radius is going to be a half. So I'm just going to put a box around that as well. Moving on, we're given a figure of the circle and we're given a coordinate, particularly the parameter t now becomes alpha. So we've just basically substituted alpha into the original equations and we're told that alpha is between 0 and pi over 2. Then we can create a rectangle. As shown, we're asked to show that the area is equal to this. So we know because the x-coordinate is cos squared alpha, then this length here is going to be cos squared alpha, and the y-coordinate of p is cos alpha sine alpha, so this height is going to be cos alpha sine alpha. Therefore, area of rectangle. By the way, this question is more of a guidance question rather than really testing us. It's just trying to help us out for presumably for part C. So it's going to be base times height cos squared alpha times cos alpha sine alpha, which gives us sine alpha cos cubed alpha. Nice. So now we're asked to find the maximum area of R. Note that alpha is between 0 and pi over 2. When alpha is equal to 0, we're actually going to get p, the coordinates, as, well, cos of 0 is 1, and squaring it is 1. And then cos alpha sine alpha, well, sine 0 is 0. So when alpha is 0, I know it can't equal 0 here. It's between 0 and pi over 2, but not inclusive. But we would get a rectangle basically that kind of just is this line. But if it's like slightly more than 0, then it would be like this rectangle here. So for small values, we're going to get this rectangle. And then when we go with pi over 2, well, cos of pi over 2 is 0. So we'll get 0 here, and cos of pi over 2 is again 0. So we get 0, 0. So suddenly we'd get a rectangle that's basically this line. But if we're just slightly before pi over 2, then we'd get this rectangle. So you can see there's going to be like an optimal area, and it's, maybe it's going to occur around here. I don't know. Are we going to try and make the length as big as possible, or maybe a height that's a bit bigger would work? But that's what we're going to find out. That's what we're trying to find, essentially. So we have R, and it's in terms of alpha, and alpha is the thing that's now varying. So what we can do is find dr by, I should have probably called this r over here, dr by d alpha. And for this, we can use the product rule. So this is u, this is v, u dash is cos alpha, v dash is 3 cos squared alpha. I'm using the chain rule here. And then I'm going to times by minus sine alpha. So then it's u dash v plus u v dash, which gives cos alpha times cos cubed alpha, so that's cos to the 4 alpha, plus u sine alpha times minus 3 cos squared alpha sine alpha, so this becomes minus 3 cos squared alpha sine squared alpha. And this will equal 0 for maximum or minimum. Or I should just say for stationary points, because in theory you could get a point of inflection going on. Okay, that means cos to the 4 alpha. Actually, I think it's just best if I just directly factorize it. So cos squared alpha minus 3 sine squared alpha is going to equal 0. Cos alpha equals 0 implies alpha is going to be pi over 2, but this is outside our range because remember it has to be strictly less than pi over 2. So that would in theory be a minimum if we did allow pi over 2. So we can now look at cos squared alpha equaling 3 sine squared alpha, which we can rearrange to give sine squared over cos squared as a third, or tan squared alpha is a third. This means that tan alpha is going to be plus or minus 1 over the square root of 3. But remember, we're only interested in values between 0 and pi over 2, so reject the negative because tan is going to be positive. So that means tan alpha equals 1 over root 3, which gives alpha as pi over 6. Remember, this is actually tan 30 or tan pi over 6 is 1 over root 3. That's just a value to be aware of. So that's our value that's going to give us our stationary point. In these sorts of questions, it's not enough to just say that is the maximum. We have to kind of, we have to show it basically. The mark scheme accepted saying that pi over 2 would have given a minimum, and therefore our pi over 6 will give a maximum. Not entirely happy with that because you can sometimes get two local minimums in a curve. Except that's only the case if there's a discontinuity, like this sort of graph would have two minimums, whereas we know our function's continuous. Okay, I think I accept it. Like we've only got these, I mean, we did get the minus answer as well. So, okay, I think to be really careful, we should really like check out the second derivative. So let's deal with cos to the 4 minus 3 cos squared sine squared. So remember that was our d r by d alpha. Okay, it's not particularly nice, but let's find the second derivative. So 4 cos to the 3 alpha times minus sine alpha. I could write this actually as 3, so this is going to be better. 3 over, so cos alpha sine alpha, wait. Sine alpha cos alpha is actually going to equal a half of sine 2 alpha. So if I square them both, I'm going to get a quarter sine squared 2 alpha. So that's going to be better. I can write it as 3 over 4 sine squared 2 alpha. Okay, much easier to differentiate now. So I'm going to be minusing 3 quarters times 2, so 3 over 2 sine 2 alpha, then the derivative, which is going to become cos 2 alpha times by 2. So actually, I get a 3 here overall. And when alpha equals pi over 6, d2r. Do you know what? I think, when you're under time pressure, like I wouldn't stress about this mark personally. I'd say something along the lines of alpha as pi over 2 gives a minimum, therefore this is a maximum, because we're losing precious time here just for minimal marks. Although this is the most, rigorous in my opinion. Okay, so when alpha is pi over 6, we're going to put it in to give minus 4 cos cubed pi over 6. See, the thing is, I don't even need to evaluate these. These are both going to be greater than 0. And then I get minus 3 sine pi over 3 cos pi over 3. And these are going to both be greater than 0 as well. This would necessarily be less than 0, which implies a maximum. It's okay to do that. Like, we could work it out. It's just, if you can just say for sure that it's going to be less than 0, then we're sorted. And hence, the maximum value of r is going to equal, we just need to take our original r, which remember was sine alpha cos cubed alpha. So sine pi over 6 cos cubed pi over 6. Sine pi over 6 is a half, whereas cos pi over 6 is root 3 over 2. So cube this one, which gives us, well, the square root of 3 cubed gives 3 root 3. And then we're going to have an eighth. So overall, it's going to be 3 root 3 over 16. Well done. One thing I just want to say, I'm just adding this to the video after I initially made it, is that right at the start I said that originally I tried to do x squared plus y squared and I got into problems, but that was because I went into double angle formula. It just made it messy. But I've looked at the mark scheme and actually it is the best way. So if we do x squared plus y squared, I'm just not going to do double angle formulae, then x is cos squared. So I'm going to get cos to the 4t, and y is sine t cos t. I'm going to get sine squared t cos squared t. Okay, so actually, I can factorize out the cos squared t to give me cos squared t plus sine squared t. And this is just 1. So x squared plus y squared is cos squared t, but actually, that's just x. So I've managed to make a Cartesian equation, and although it doesn't quite look like a circle at the moment, it is at least a Cartesian equation, and it must be equivalent to what we otherwise found. And we just need to complete the square, so we can write down x squared minus x plus y squared equals 0, then x minus a half squared. That'll give me my x squared minus my x, and I'll get a plus a half squared, so I need to minus a half squared or minus a quarter. So x minus a half squared plus y squared is going to equal a quarter, which I could write as a half squared. So this is just an alternative way to get the center as a half 0 and the radius equal to a half. Yeah, that is a really nice method.